Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Fikri bin Abdul Rahman Sidek. So today I want to present about my PSM1. My title is Development of Motion Sensor Device for Athlete Posture Assessment during ERGOMETER Rowing Machine Training. Introduction. The application of the electronic device to performance and body posture in sport is not very widespread at present. The movement and posture of the human body can be evaluate performance while doing sport activities is very important to obtain the necessary data and also prevent injuries. This rowing exercise requires proper training to get the right training position. However, what are the ways and application that can be used to facilitate athletes who are just starting the venture into the sport in rowing? Electronic component will be used into the rowing machine so that users of the rowing machine can evaluate their performance while exercising. The sensor will be used to serve as a body movement sensor, the seat position of the rowing machine and some handle position. All these sensors will be controlled by the NodeMCU. And for the problem statement, rowing is a good exercise which works both upper and lower body at the same time. Common rowing injuries occur mainly around the low back and the chest wall. They might be called ribs stress injuries. Rowing exercise may injure the affected part of the muscle to beginner athletes because the body posture during exercise is not accurate. The position of the body is very important to be in the right position in order to avoid being exposed to unwanted hazard. Have difficulty getting used to while doing rowing exercise because this exercise requires accuracy in body position. And for the objective, number one is to develop an appropriate position in rowing training by referring REBA approach, to apply sensor and alarm indicator for detecting the best position athlete's body. And number three is to create the controller for the sensor using NodeMCU. And for the scope, each athlete has a different height and the sensor readings against each height range will be different. The height range of the athlete who will be involved is 155 cm, 165 cm and 175 cm. Number two, limited to beginner rowing athlete who have just tried these sports as they are not yet proficient with proper body position. Number three is only the back of the athlete's body, legs, hand and the seat of the rowing machine are detected using sensor. And for the literature review, several relevant studies have been obtained for use as a literature review. It provides an overview of current knowledge and allows to identify relevant theories, methods and gaps in existing research. And for the previous project 1, which is development and characterization of the high aspect ratio vertical FET sensor for motion detection. Initial sensor for car dynamics, stabilization, acceleration, detection, human body motion monitoring are popular MEMS application. The figure shows a schematic structure of the vertical FET, and the system consists of a laterally moving spring mesh system. There are two arms at the systematic mesh. Transistor regions are located at the end of the arms. The moving mesh, which is single crystalline silicon, is acting as a gate electrode. And for the previous project 2, which is magnet integrated shirt for upper body posture detection using wearable magnet sensor. Wearable sensing through clothes reduce the need of the cumbersome sensor, allowing for a more practical approach to long-term body monitoring. A loose shirt is recommended as the proposed platform in the wearable solution to maximize the effectiveness. The goal is to use a magnetic sensor to determine the relative location of small magnets on the shirt. Upper body posture will be determined using this pose. The figure shows a grid of nickel-plated neodymium magnet is placed in a 3x3 grid on a T-shirt. The magnets are placed on the shirt from the proposed system. And for the previous project 3, single pass proximal distance sensor with thermoacoustic transmitter. The thermoacoustic transmitter can emit very short ultrasound because it doesn't have inertia and mechanical vibration. Thus, it can reduce influence of the emission. And for the conclusion, from the literature review that has been discussed, we can decide to choose what sensor is suitable for use in this project. The first sensor is an ultrasonic sensor and the IR sensor. And for the methodology, under the title of this methodology, we'll discuss the way to make this project a success. This is a flowchart project work plan. And this is a PSM2 planning. And this is for the block diagram. The signal from the ultrasonic sensor will be transferred to NodeMCU 1 by wired, and the signal from the IR sensor 2 will also be transferred to NodeMCU 1 by wired. Signal from IR sensor 1 will be transferred to NodeMCU 2 by wired. Data from NodeMCU 2 will be sent wirelessly to NodeMCU 1. NodeMCU 1 will process the signal obtained from the sensor and will illuminate the LED either red or green. The data will also be sent wirelessly to LabVIEW for analysis. And for the component placement, the IR sensor 1 will be placed on the handle of the rowing machine to detect the athlete chest, whether it is closest to the handle during exercise or not. There is a microcontroller that will both be in the handle of the rowing sensor. The IR sensor 2 is placed at the bottom to detect the presence of the athlete legs during this rowing exercise. Ultrasonic sensor will be placed at the back of the rowing sensor machine to detect the distance taken by the athlete to push the seat while doing rowing exercise. And this is for the component required in this project 1. Number 1 is IR sensor 1. IR sensor 1 will act as a detector for the chest area. And NodeMCU 2 ultrasonic sensor, NodeMCU 1. And for the software required in this project, Arduino is used in this project to create a program to program NodeMCU. Arduino is used because it is easy to understand the computer language and is familiar with this software. And for the LabVIEW is used in this project to analyze the posture of an athlete's body by extracting data taken from NodeMCU. NodeMCU will send data to LabVIEW wirelessly. LabVIEW will be displayed using a computer. And for the Proteus is used in this project to create a circuit design that shows the wire connect between the hardware. And for the system flowchart, the figures show the system flowchart. First, when the athlete want to use this rowing machine, they should choose their height range. The sensor will be functional and ready to detect the presence of the human body. During the exercise, the athletes should strengthen their legs, pull the handle up to the chest with straight hands and push the seat up to the proper distance. If these three aspects are met, then all three LED will be green. As long as the sensor does not detect the human body, the red LED will remain light up. And for the circuit drawing is designed using Proteus. The wire connection has already been set. The microcontroller that will be used in this project is able to give power supply for all sensors used. the NodeMCU microcontroller supplies has an output voltage value of the 5 volt and is capable to turning on all sensor. The NodeMCU to and will be supplied using 5 volts battery. Expected result. This developed project is able to help them to train more efficiently and with disciplines. It can reduce injuries suffered by the athlete during rowing training. The sensor used will work well to detect the body part of the athlete in question. The sensor will be accurately detect the athlete's body posture while doing this rowing exercise. Athlete can also perform rowing exercise with a great discipline and efficiency. And conclusion, this project only needs 2 types of sensor as input, which is IR sensor and ultrasonic. This project also applies the use of sensor to analyze the posture of human body. Not only rowing sport can be analyzed, but other sports such as cycling can also be analyzed by using this electronic tool. The NodeMCU is used as a microcontroller to process the inputs and signal obtained from the sensor. Testing with the real athlete will important to get the right setting with its operating. That's all from me. Thank you.